So now that we have a little bit of understanding of how the architecture is going to go, let's get started on actually writing some Move code. So now that we have this empty folder in our VS Code set up, recall that we installed the toml, the Move syntax, and the Move analyzer extensions, and I also have Vim installed because I personally prefer to use Vim. So we're going to run the sui move new command, and we're going to give it a name, and we're just going to call it. We're going to call our package. We're not going to call it contracts. Let's call it sui_place. And I prefer to use underscores. I don't think it lets you even do. Hyphens. So now that we have this command run, it creates a folder, and this is where we're going to start all of our contracts. And if we look at this move.toml, this should be auto-generated for us. It'll tell us what name and version it is, and this is just some stuff. This is the dependency for the Sui standard library, so that the Move compiler can link to Sui. Because recall that Move is a language that's used across multiple different blockchains. For example, the Aptos version of Move is very different from the Sui version of Move, and so it needs to say that, hey, this is a Sui specific project. And also this addresses is, we're not going to go over exactly what this means, but it's important that this is there. And we're actually going to rename this folder to contracts. You can leave it like that, but personal preference, I prefer to have a contracts folder in my base folder. And so what we're going to do is we're going to, in the sources, we're going to do a new file. We're going to call it we're going to call it actually place. We're going to call it place.move. And before we start writing any code, it's always best practice to do a Git repository. So we're going to do git init, and I'm actually going to change the branch by default to main instead of master as it typically is. Main, just to make it more in line with what GitHub does. So now that we are currently in our, so we're going to add status, and we're going to commit everything to initial commit. I'm also going to create a gitignore file .gitignore, which we are going to add to later once we start building, and there's stuff in the build that we don't want to have committed to source. So now that we have this place.move, let's start writing code. So the first thing that you have to type is every single piece of Move code has to live in a module, and there can be multiple modules per package. So in this instance, sui-place is the package, and we're going to just use the same name as the file name, so we're going to call it place. This is going to be the module. And in every module, there's going to be certain import statements. So, for example, one thing we know is that we're going to store pixels in vectors. So we're just going to, at the start, we know we're going to import a vector. So we're going to import a vector from standard vector. Somewhat similar to a lot of the syntax here, you'll notice is pretty similar to Rust, but there are some important changes. We're also going to start doing objects. I think it's a good practice whenever you're writing. I think software development in general, it's always really important to have your actual data structures nailed down first, because the way that your data structures are implemented and the way that you're storing data is extremely important when you're thinking about how to do operations on that data. So as we talked about earlier, we're going to have two objects, and the way that you define an object type is you use this struct keyword. We're going to do struct place, and we're going to give it two things. These things are called abilities. So we have key and store. Key means that what key means is that you can. Key means that this struct is an object. And because a struct is an object, every single object in Sui, it has to have the first static field. Remember, these are static fields, not dynamic fields that we're defining here. It has to have the first field as UID. And UID is it's somewhat of a magic type in Sui. Every single object has to have this ID with this UID type. And what key means is that this is an object. It'll have its own object ID. You can leave out key, but that means that it won't be an object ID. It won't be able to store any data, and the only use that a struct without key has is if it's like an intermediate data structure that you're using inside of a transaction, like a function and nowhere else, or if you just want some kind of wrapper into another thing. But key is what lets it store by itself. It doesn't need to be inside of another object. And what store means is that it can be stored inside of another object. If it doesn't have store, you cannot transfer it, and you cannot store it into another object. So place, we're just going to leave it like that, right? It has no other static fields. This is just a logical. The only reason that we're using place is because we're going to put some dynamic fields on it, and you don't declare dynamic fields when you're instantiating these object structs. And we're also going to have another struct. We're going to have, of course, the quadrant, and the quadrant also has key, it has store, and it has to have ID because every single move object has to have ID. And yes, and then we're going to put the board on. This is where the board is actually going to be stored. We're going to do vector u32. So this is a two-dimensional vector. Vector is array. The difference between array and vector is that array is fixed. Although there isn't actually an array type in Sui, it's all done with vector. So array types that might exist in other languages don't quite exist on Sui, but vector will do just fine for us. And we're also, just for like debugging purposes, we're going to include this quadrant ID. I don't think we're actually going to need this, but it's good for debugging. It just makes our lives easier. So also in Move, there is, instead of constructor functions like you would have in Solidity, there's this init function. And the init function is special. It has to have this certain syntax, mute tx context. So any function with this signature, fun init, ctx, mutable reference to the context, that's going to be an init function. This is going to run exactly once when the contract is deployed. And we're going to leave this blank for now. To do. Also, on our interface, we're going to define a couple of. Let's define the public-facing methods first. So whenever you're writing a function that can be called from outside of the smart contract, like from a dry run transaction or from just like a regular transaction, any way that you want to interface with the contract, it needs to be public. One thing to note is that somewhere in the docs it says public entry. However, public entry is being deprecated. Just public will do just fine. It does the exact same thing. So if you see public entry fun, that's the exact same thing as just doing public fun. I recommend that you just do public fun too. So we need two public functions. We're going to do the set pixel add, of course, is what we've been talking about, which is going to take place. It's going to take a mutable reference to this place struct. And it's also going to take an x, a y, and a color. X is going to be a u64, which is a 64-bit integer or an 8-byte integer. X, y, excuse me. Y is also going to be a u64. And then we're going to put color, which is going to be a u32. Great. And if you don't understand why a U32 is a color, I'd recommend that you watch the previous video. And the other public interface function that we want to have is this public get quadrants. And this is going to take a place, a mutable reference to place. It is also going to take, actually that is all it's going to take. And it's going to return a vector of addresses. And that is all we need. What we're using this for is that somewhere in the deploy, we're going to need, my bad, it needs to be function. Yeah, the reason why we're making this is because later on when it comes time to deploy, it's going to be easier for us when writing deploy scripts to just call this function using a dry run transaction, using a read-only transaction to get this vector of addresses, rather than it's going to be to do some to like directly introspect the object and then find the dynamic fields and then go from there. Although we'll do this. Although we'll go in more depth on why we need this get quadrants later. So let's go through some pseudocode, or not some pseudocode, but we'll write some comments on what exactly we want to do in each of these functions. So set pixel at is where most of the magic happens, and what we're going to do is we first want to assert that pixels are that xy is in bounds. And the reason why we're doing that is because if you have a vector and you try to look up like let's say you have a vector of length 10 and you try to look up like the 20th element, you'll run into an abort and it won't have the most helpful error message. So we want to check and make sure that the arguments are correct as soon as possible, and then abort if so with a good error message, and then it will it just makes it easier for everybody and easier to debug code. And it means that we don't have to worry about things being incorrect later on when we go to write other functions. And then what we need to do, as we discussed previously, is we need to get quadrant from dynamic field object mapping on place. But in order to do that, remember, because we're storing the quadrants as a dynamic field mapping from like a quadrant ID to the quadrant. So we need to figure out which quadrant ID we're going to use. And recall that we're doing like a zero, like if this is the left quadrant and this is the right quadrant, this is the bottom left and bottom right, it's going to be 0 quadrant, 1, 2, 3. So we have to do some pixel math in order to make sure that that works. So get quadrant E from x, y. And then we're going to use that quadrant ID for the dynamic field lookup. And then we need to actually place the pixel. So place the pixel in the quadrant. Great. What is get quadrants going to do? So get quadrants has to create a empty vector, iterate from 0 to 3, which is all of our quadrant IDs. Look up object mapping from quadrant ID, append ID of each quadrant to vector, and then we want to return that vector. And the reason why we're getting this error is because we are telling it, hey, we want to give you, like, this is a function that takes this and returns a vector, but right now we're not returning anything. This is called a unit. It means like nothing. You're not returning anything. It's analogous to like undefined in JavaScript. And we're just gonna let that error keep going for now. It's not a big deal. So besides the two functions, we need to figure out what's going on in init. So what happens in init? Well, what happens in init is you need to create place object, create 4 quadrants, initialize pixel grid, each pixel grid, remember because there's 4 pixel grids, to white, place 4 quadrants as dynamic fields with quadrant ID on place. And then we're going to want to make place a shared object. So let's make some helpers for this too. I think that one weakness of Move at the moment is that there isn't the greatest. Hopefully this is going to be changed. In theory, they're adding more I think they have some unannounced features in the mix. So in theory, that they are getting better at this. This is something they do care about. They're trying to go forward, but they also want like the one of the biggest problems in Move right now is that there isn't a good way to do things with vectors. You have to do this very C style, like, iterate through the vector and push back, and there's no like mapping, and there's no reduce. There's no nice combinators that like a more functional language like JavaScript has. So we're going to write a couple of just helpers for that. And in order to write a helper function, so this is a function that we don't need the outside world to be able to call. Instead of doing public, we're just going to write fun. And so the one fun that we want to do is we want to make a row. And it's going to take a length. And this length is going to be U64. And it's going to return a vector of U32. So this is just going to create a vector with 200, well, I guess in this instance, in this helper function, it's variable, right? We're taking it as a parameter, but we're just going to create a big vector that has the pixel information for one of the rows in one of these quadrant grids. So pretty simple. Init vector, empty vector, append length number of U32s. We're actually it's going to be 0 by default. Actually, no, it's not going to be 0. It's going to be the color white. So we're going to initialize it to white, and we're going to create 200 of those, and then we're going to return the vector. And very similar to that, we're also going to have this function make board. Let's call it actually make pixel grid. Yeah, no, we're going to call it make quadrant pixels. And this also takes a length of 64. And this is going to return a vector, again, 2D array, a vector of U32. And this is going to init empty vector, append new and then we're going to use make quadrant pixels in our init function to initialize the quadrants. And down here, set pixel, we're going to we would really like this helper function. Public, actually not a public. Again, public is only for functions that you want the outside world to call. Fun get quadrant ID x U64 y U64. And actually I'm going to change my mind. We are going to put public here, and the reason why is because this is a function. All it does is it takes 2 pixels, and it's actually going to return also a U64. And if you like, typically private functions are like, the reason why you'd make a function private is because you don't want to clutter up the move code, or like there's some kind of data invariant. But here we're not passing in objects. We're not really passing in any data. This is just U64s, giving it U64s and returning U64s. So it doesn't matter if it's public or private. In Solidity, it actually does matter. In Solidity, functions that are private are actually cheaper to call. Like internal functions that aren't accessible to the outside world are actually cheaper to call if you only intend to use it internally. So not including public on something can be a gas optimization. But in Move, I don't believe that's the case. And in Move, gas ID or gas is so cheap anyway that I wouldn't really worry about it at this point. So get quadrant ID. What this is going to do is take x, y, return which quadrant x, y falls in. Yeah, so all it's going to do is just take x, y, return what quadrant, which quadrant, the ID of the quadrant that it's associated with. So looking at this function, this get quadrant ID function, I think this is a pretty good candidate to start off with. This is the first code that we're going to write here in Move. And here I have a diagram of, this is the grid again, the place grid, and these are the quadrants. Remember 0, 1, 2, 3, 4. And so on the top here we have our x coordinate. So this is going to be x equals 0, and this is going to be x equals 400, or actually, well, x equals 399. And here, over here is going to be our y coordinate, where again, this is y equals 0, and this is y equals 399. And so we're going to do this with like a nested if statement. And so we're going to do if x is less than 200. So this is asking, so if x, again, because this is 200, 0, 200, 0, 200, and then 399. If this is less than 200, it's going to fall into the 0 or the 2 quadrant, depending on the y value. And then if it's otherwise, it's going to either be 1 or 3. So we're going to do like this. So if, and then we're going to do this other if statement. If y is less than 200, then we're going to return 0. Else, we're going to return 2. And similarly, in this other branch, we're going to have if y is less than 200. We're going to do, right, so x is greater than 200, y is less than 200, that means the 1. Otherwise, it means 3. And we're going to tidy up this code a little bit. Control S to save. It's giving us an error. Whoops. Yep, no, never mind, the error resolved itself. So we're going to tidy up this code a little bit. So you may note that there's no return statement. And that's because move, and Rust does this too, but in move, every expression, the last statement in this is like an implicit return. So if I put a semicolon here, it's going to, well, first it's going to complain about we're returning nothing, but it's expecting U64. But now if we type 4, all of a sudden, even this is invalid code, it'll compile. And this is because this 4 is the last expression that is at the end of the expression block. It's just going to act as if there wasn't a return statement here. And we can't have a return statement here. It's just optional. We don't need it. If implicit return wasn't a thing in Sui, we'd have to, or in Move rather, we'd have to write an explicit return before all of these, and that'd be a little bit annoying. And this is okay because the compiler can determine that no matter what the configuration of x and y is, in every possible condition of the branch, where there's always going to be this implicit return value. So this is the recommended way of writing a ternary. This is equivalent to, like in JavaScript, 200 plus 2. This is these are equivalent in code, and there's also the same thing you do in like Python and Rust. So get quadrant ID is finished. Now we're gonna return our attention to these make row and make quadrant pixels, and this is also somewhat simple. Remember how I was talking about how Sui did not have the best, and Move did not have the best tools for using loops and for using vectors? Well, we're gonna have to suffer through that right now, because we unfortunately have to use while loops. And outside of Sui, I don't think I ever use while loops. I pretty much always just use MapReduce. So really have to go back to the basics here. So the first thing we're gonna do is we're gonna initialize an empty vector. And remember, up at the top here, how we imported this use std vector. Well, that's gonna come in handy now. We're going to use that. We're going to do vector. We're going to do vector empty, and we're going to assign that to a variable. So we're going to do, remember, because this is a row, so vector empty, and we're going to do, this needs to be AU32. And to start, we're actually going to just return the row, just so our compilation error goes away. And then, because we have to use while loops, because there is no for loops in Sui, we have to do kind of things the old-fashioned way. So we have to do a let I equal 0 while I is less than length. And then at the end, we're going to do I equals I plus 1. So now inside our loop, we're going to start pushing back the U32s to our row. So we're going to do vector push back. And this is equivalent to just like append or push in JavaScript. And we need to give it a mutable reference to row, which is our empty vector, or to be filled vector. So now we have to figure out what number we're going to put in here that represents this this color, which is white. So we're gonna recall that this is hexadecimal, so we need to convert this hex to decimal. 1, 2, 3, 4, 5, 6. Convert decimal value right here, and just copy paste that in. And another thing you can do in Move, just to make things a little bit more readable, is we're going to put underscores every 3 decimal places, just to make it a little bit more readable. It does not change the value, it just makes it more readable. And we're going to add a semicolon, because otherwise it's going to complain. And at the end, it says unexpected row. It's because we need to add a semicolon there. I think that it's another kind of issue that I keep running into is that it's not entirely clear when you can use semicolons and when you can leave them out. And in a language like JavaScript, they tried their hardest to make semicolons completely optional. So you can leave out the semicolons, you can put them in, it really doesn't matter. And in fact, later on in TypeScript, I don't use semicolons at all. But even in a language like Rust, where most of the time they require that you use semicolons, sometimes you need semicolons on like ifs and fors and whiles, and sometimes you don't. So the rules aren't always consistent. Here, it's kind of more so. It's not always entirely obvious when you should use a semicolon, when you shouldn't. I personally would recommend that you always use a semicolon. If you use a semicolon, it complains at you, then just try to get rid of it. And again, if you don't need to use a semicolon when you really want to return something at the end of when you don't want to return something at the end of an expression like this. So this make row, this works. And we're going to do a very similar thing to this quadrant pixels. So we're going to do like grid equals, same thing, vector, empty, u32. And I'm actually just going to completely copy paste this code because I don't want to rewrite it. This would work, but it's wrong because given a mutable reference, we change the variable name, and we also want to do a make, what did we call this? We called it make row. Called it make row, and we're just going to pass in the same length because we want it to be square. And yeah, it doesn't work, and the reason why it doesn't work is because here in this type parameter, we're saying that we want a vector of u32, right? So as we have it, this grid has a type of vector u32. But remember, right, we want a grid, so we want a 2D array. We want a vector inside of a vector, and so we really want grid is to be this. And this is going to complain because what we're giving it is not a vector of u32, it's just going to be a vector of u32. So we have to change this to be vector of u32. So that we still have this, we forgot to change the name of this. We're going to change this to grid. So I'm going to come back here, and I'm going to look at this ampersand mute row. And at first this might be a little bit confusing. And again, I'd really recommend, if you aren't super familiar with this, to go look at the Sui, the tutorials put out by the Sui Foundation, because I think that's going to be a more comprehensive example. And really this tutorial isn't about Move, this is about integrating Move with front end and React. And so what this is saying is that we can't just put row here. And if we got rid of this ampersand mute row and just put row, we would come back with a compiler error that it said that we gave it a vector of u32, but what it really needs is a mutable reference to the vector. So we can fix that by setting this to a vector, setting this to an ampersand, so a mutable reference, by putting this mutable reference in front of it. So now we look at this code, we see that we get a couple of errors. One such error is that we are using this UID, but it says it's unbound, it doesn't know what it is. And so that means that we have to import this. Specifically, we're going to import it from Sui object, no space, object, UID, put a semicolon. And we also need this transaction context, CTX mutable reference to transaction context. We need to import the transaction context type, tx context from tx_context. And that will get rid of the errors for us. So after getting our helper functions implemented, let's go ahead and start on init. So the first thing that we have to do, recall according to the pseudocode, is to create a place object, and to do that we're going to use the object constructor. We're going to use this syntax, place, and recall that place, the only thing that place needs, because we're not storing any static fields, is a new UID. And the way that you create a new ID is you call this object, this new function that's on object. So you can do, usually in Move code, they specify, they don't import the new function, they import the object namespace and then use the function specifier from there, but we're just going to import the function directly. And this gives us a place variable. However, you will note, oh yes, incorrect, we need to always make sure the semicolon is there. It's giving us an error because we need to pass in ctx. And now it's giving an error because it says that the place contains a value and we don't have drop ability, so it must be consumed before the function returns. And because we already know that we're going to be making place a shared object, we can do that using the share object function that we are importing from sui transfer share object. And again, this is going to make it so anybody can call any. It's going to make this place object ID available to use as this parameter by anybody. And again, if it was just owned by one account, or if it was frozen, if you try to use the object ID of place as an argument for this function, the Move VM would throw an error when it comes time to put it in a validator. And so we're going to put the place. We're going to pass that as an argument to the share object place, and put the semicolon, and that fixes the issue. So now we're going to create 4 quadrants and place those 4 quadrants as dynamic fields with the quadrant ID on place. And we're going to do this with a while loop because it's just a little bit easier and less code. We're going to make let I equals 0, and while I is less than 4, remember to add the semicolon, and at the end you want to increment equals I plus 1. And inside this while loop, what we're going to do is we're going to call the dynamic, we're going to use this dynamic object field namespace, and let's actually change this so the code's a little bit more readable. So we're just going to import the namespace rather than any functions on that namespace. And now we can call dynamic object add, dynamic object field add. And what add does is it takes, let's go to the definition of this. No definition found because sometimes if you try to right click, and even though you know that there's a definition here, it says it won't, or it says no definition found for add. And the reason why that I found is that if there are any errors in the program, if there's any like syntax errors or type errors, then it will not. This go to definition won't work. So yeah, we'll just implement the code, then we can talk about how it works later when it all compiles. So this takes 3 arguments. It takes the ID of place as a mutable reference. It also takes the key that we want to set the dynamic field to, and we're going to, this is the, again, quadrant 0, 1, 2, 3. That's the key is going to be the I as a quadrant ID. And we're going to set the board to, we're going to set the object in this dynamic field to be a new quadrant that we're instantiating the same way that we're instantiating place. And because, again, quadrant is its own object, it's going to have its own ID. And we're going to create that the same way that we did it before. And this also has the, what do we call this? Yeah, so it had the quadrant ID, which is U8, and we had the board. So quadrant ID, this is going to be I, and the board is going to be make quadrant pixels. Recall that we already created this helper function, so we're just calling the helper function that we created here, and we're going to give it a length of 200. And actually we don't need the semicolon here again because we're using it as an argument. It's not a standalone statement. We're using it as an argument and directly putting it into this add call. Press save, Does it give us any errors? No, it does not. So yeah, so notice how before when I did go to definition, there it said no definition found, and then now that once there's no errors in this project and it compiles, it'll bring us directly to the definition. And this is really useful to see. I would strongly recommend going through this code. At the moment, the documentation for like all of the Sui built-ins, like vector, table, like object bag, all this kind of stuff, that it's very useful. You definitely want to use it, but the documentation online isn't really there. So the best documentation I'd recommend is to just use one of these functions in some move code. Right click, go to definition. It'll take you. There's this like it stores it in the .move folder, so it's a little bit hard to get all the way into this file, so it just makes it easier to find it. But then once you're here, you can see all of the different functions you can use, and there's some decent documentation on this. So that's really good to know. And now that we have that created, that is going to work, and this is going to, again, recall that this init function is going to be called whenever you construct and when you deploy the smart contract to a chain. And now we can go ahead and work on this set pixel at command. So the first thing we need to do is assert, and for that we're going to use this assert macro, which it's, I guess at the moment it is, there's only, this is similar to the way macros are implemented in Rust, although at the moment there aren't that many macros. I'm actually not entirely sure if there are any more macros than just assert. I believe they are adding more though, not entirely sure which ones, but this is effectively just a function. And this is going to need two things. The first thing is, this is pretty much how, the same way that works in Solidity. So the first argument is going to be whatever condition you want to check. So we want to assert, we want to make sure that the x and the y values are completely valid pixels. So that x has to be less than 400. Again, it can't be 400 because it's the length minus 1. And we want to make sure that it's both less than 400, the x is both less than 400, and that the y is less than 400. And the second argument is going to be the integer is analogous to an error code that we want to show whenever that assertion doesn't hold. And we're going to implement a constant up here, const. And the way Move does it, or best practice for naming this, is the first is going to be e, and then just like a name, a short, simple, what does this error mean? And invalid chord, I feel, is a good name for this. And we have to actually specify I like to make these U64s, and we're going to specify the type and set that to whatever integer. You can reuse this, like say for example, two functions have asserts. It's totally okay, totally fine to reuse this as long as it makes sense. Like if you have two functions where you need to make the same check that the chords are valid, it's fine to reuse the same error code. And if you have, let's say you have two asserts where the error codes mean something else, it's like some other error code, you'd want to make a second number and just increment it like this, so you'd have two. The numbers, like the actual values that these are, don't really matter, because you would just, in the front end, you would just know what they are when you're coding the front end and know how to handle them. So now that we have this assert, we want to e invalid chord, and this works. So now again we call that get quadrant ID, and so this is just calling the function that we already defined. No, I didn't. Okay, so let quadrant ID equals, we're calling a private function. We're calling our private helper function. Get quadrant ID, put in the x, put in the y. And now we're going to use that quadrant ID to look up the quadrant, the dynamic object place. We're going to do, look at my notes, we're going to use dynamic object field, : we're going to use borrow mute. So borrow, instead of having there's an add function, but instead of having a get function, they call it borrow. And also borrow mute. So the difference is borrow is when you want to get something from a collection and you don't need to modify it, but you need borrow mute when you want to return a mutable reference, and that way you can modify whatever you're getting from the works the same way on vector, and yeah, we're gonna use that function later in vector. When we're using dynamic object fields, one of the important nuances around dynamic objects is that, or dynamic fields in general, is that they respect the types of the keys and the types of the values. So you have to specify what like types do you want the key and what types you want the value to be. For example, like let's say that I had a U8, like this is going to be this type parameter, this is the type of the value, and we're getting a quadrant from here, so this is going to be this U8 is going to be the type of the key, and this quadrant is going to be the type of the value. So for example, this is going to be completely different than U64, even if they're both 0, right? One maps, these are going to be completely separate entries, right? From a 0 of type U8 and a 0 of type U64. So that's definitely something to keep in mind. And remember that we specified the keys as U8s, so that's going to be correct. And we're going to put in here the place that we're getting, place.id, and it requires the object ID of the object that we want to do the lookup on. And we also need the quadrant ID that we just calculated. And I'm going to go ahead and I'm going to make this a little bit, a little bit wider. And remember to put the semicolon. We want to assign this to a variable so we can, because again, this is just a quadrant, we still need to modify the pixel. So let quadrant equals that. Save. So remember that I said that the types need to be correct. Well, when we wrote this function, we decided to return a U64 instead of a U8. And actually now I'm realizing that's a mistake. This should be a U8. And once we define that, this will resolve. Because we're mapping the actual dynamic field key type is a U8 and we're returning a U64, that's not going to work. So now that we have our quadrant, we are given this quadrant dot, what did we call it? We called it board. So the actual pixels are all on this board. And we need to do a double array access. Remember that the first, we're trying to do this in JavaScript essentially, right? So this is going to be our X and this is going to be our Y. But instead of using this syntax, we actually have the vector borrow mute. Again, borrow mute because we want to change it once we get it. We're going to change the pixel eventually. And we want the X. However, because this is a quadrant, it isn't the full board. We need to do the modulus of 200. And remember, the focus of this tutorial is not on how does the sui-place work, how does pixel math work. The focus of this is not even on how to write move. The focus of this is how to get move code deployed, how to get the project started, and how to actually structure your folder so that you can get something real loaded. And so we're going to want to do the same thing to get the Y value of the pixel, or the actual raw pixel value that's held at the Y coordinate of the vector row. So we're going to wrap it with this borrow mute call. Same situation, and Y modulo 200. And it gives me an error because could not infer this type. Try an annotation. So we want to store in this pixel equals mute U32. Oh, wrong syntax. The type of that needs to be mute U32, and we're going to assign that to the result of this call. And now it's giving us this error. So at the moment, we're giving it, whenever we want to pass a mutable reference, you need to specify that it's a mutable reference. And even though, for example, here, if you see what is place, well, place is defined as a mutable reference to place. But after we read the ID off of the mutable reference, and once we read that ID, now it just becomes a regular object. The UID object, place.id itself is a UID object, and then we have to specify again that we want to give it as a mutable reference. And we're going to place that $mute there, and that's going to solve that issue for us. And I'm going to adjust that so it's a little bit easier to read. And now we have this, the mutable reference to E32 is a pixel. And now to actually place, to set the update the color, we're going to dereference the pixel. We're going to use it as an L value. We're going to dereference that. We're going to say, the way to read this is that we want to change the value associated with this reference to our color, which is passed in as a parameter. And now that that compiles, that is going to be the entire code. And we're back. If you noticed during that last piece of code, there was a little bit of a warning that appeared under this pixel and under this color saying that it was unused. I'm not entirely sure why that happened. I think it was an issue, some kind of bug with Move Analyzer, and I just closed and reopened the program to fix it. So, I'm pretty confident that this code is correct and will compile, but I'm not sure. So we're going to open up, we're going to open up the contracts and make sure that we're in the same folder of move.toml, and we're just going to make sure that it compiles, and we're going to do by using the sui-move build command. And note that it just added a bunch of folders into this repository, and it says that if we do git status, it says that a bunch of these, it gives us this build folder, it gives us this buildinfo.yaml, it gives us this sources, and these are things that we actually don't want to get committed into the source tree. And so we can fix that. We can do, we can add all of those. I'm just going to add those manually to the gitignore, and we're going to do that by doing contracts. We have this .gitignore file in our source, or this root folder that we created. And note that it's definitely, you don't want to do contracts, because that's going to ensure that every single folder in this is going to be omitted from the Git tree. We want to specify it, everything in build we don't want, and this still gives us our sources. And remember, earlier I was discussing that we actually do want this move.log to be committed.